Hello everyone. What we're going to focus on in this video is the inverse of a square matrix. If M is a matrix, then the inverse of M is written as M to the negative 1. And this means the inverse of M equals to 1 over the determinant multiplied by the adjoint of M. So that's how we determine the inverse of a matrix, right? So we must divide 1 by the determinant of the matrix multiplied by the adjoint of that matrix. And that gives us the inverse of the matrix. So here I have matrix M is equal to -3, 2, -4, 1. In order to determine the inverse of M, I need to determine the determinant of M, and I need to find the adjoint of M. So let's focus on the determinant of M first. So the determinant of M is going to equal to the product of the main diagonal. And here, let's highlight the main diagonal. The main diagonal is going to be -3, 1, right? So it's the product of the main diagonal, which is -3 times 1. All of that in bracket. Subtract the product of the minor diagonal, which is going to be 2 times -4. So it's going to be 2 times -4 -3 times 1, that's going to give us -3, minus 2 times -4, that's going to give us -8. Can put this -8 in a bracket. So what we have here is -3 minus 8. Negative times negative, that's going to give us positive, or you just connect both negative sign to get one sign, which is plus. So what we really have is -3 plus 8, and that's going to give us a +5. So therefore, the determinant of M is equal to 5. Now what I need to determine is the adjoint of M. So the adjoint of M is going to equal to. Now we need to switch the position of the term in the main diagonal, right? So where -3 is, I'm going to write 1, and where 1 is, I'm going to write -3. And I need to switch the sign of the terms in the minor diagonal. So instead of writing back 2, I'm going to write -2. And instead of writing -4, I'm going to write +4. And that's the adjoint of M. Therefore, the inverse of M, which is matrix M in this case, is going to equal to 1 divided by the determinant, and the determinant here is 5. It's going to be 1 over 5, right? Times the adjoint of M, and the adjoint of M here is going to be the matrix 1, -2, 4, -3. And if we simplify this, therefore, we will get a final answer of the inverse of M is going to equal to 1 times 1/5. That's going to just give us 1/5. And 1/5 times -2, that's going to give us -2/5. And 1/5 times 4, that's just going to give us 4/5. And -3 times 1/5, that's going to give us -3/5. And we're finished. So therefore, the inverse of matrix M is going to equal to 1/5, -2/5, 4/5, -3/5. So here I have matrix P is defined as 1, 4, 1, -2. And what we want to do is to find the inverse of P. Now we know the inverse of P. We can find the inverse of P by having 1 divided by the determinant of P, right? Multiply by the adjoint of P, or P adjoint. Alright? Now, we can do this in one go, and this is going to equal to 1 all over the determinant. Well, how do we find the determinant? It is the product of the leading diagonal or the mean diagonal. So here, the mean diagonal, if I highlight it, it's going to be 1, -2. Right? So it's going to be 1 times -2 in bracket minus the minor diagonal, which is going to be 1 times 4. All of this multiplied by the adjoint of P. And how we determine the adjoint of P, we're going to switch the terms in the main diagonal. So -2 is going to take the place of 1, and 1 is going to take the place of -2, and we're going to switch the signs of the other term. So it's going to be -4 -1. All we need to do is to simplify this. So it's going to be 1 all over 1 times -2, that's going to give us -2, minus 1 times 4, that's going to give us 4. All of this multiplied by our adjoint here, which is -2, -1, -4, and +1. So it's going to be 1 over -6 times the adjoint, which is -2, -1, -4, and +1. So you can leave your answer as is, or you can distribute the -1/6 to each term inside of the bracket. Alright, so this would be the answer here. Now matrix R is equal to 3, 5, 2, 4. Now what we want to determine is the inverse of R. So we know that the inverse of R is going to equal to 1 over the determinant times the adjoint of the matrix, right? So we need to determine the determinant. So it's going to be 1 over the determinant of the matrix, which is going to be 3 times 4. That's going to give us 12. So that's going to be 12 minus 2 times 5. That's going to be 10. All of that multiplied by the adjoint of the matrix. And all we need to do is to switch the position of the terms in the leading diagonal. So this is going to be 4, 3. Change the sign of the others. So this is going to be minus 5 and 2 here. Minus 2. So 1 over 1 over 12 minus 10, that's just a half. So all this is equal to a half times the adjoint of the matrix, which is just 4, negative 5, negative 2, and positive 3. We can leave our answer here, or we can distribute the half to each term. So let's distribute the half to each term. A half times 4, that's just going to give us 2. Negative 5 times a half, that's going to give us minus 5 over 2. A half times negative 2, that's just going to give us negative 1. And 3 times a half, that's going to give us 3 halves. So therefore, the inverse of R is going to equal to 2, negative 5 over 2, negative 1, 3 over 2. Thank you for watching, and do enjoy the rest of your day.